you have to make your connections with this. So if you're going to reabsorb bicarbonate, then this is the one, reabsorbing it from this fluid out here, this filtrate. Here, it's, all right, how do you get rid of hydrogen ions? So if you're too acidic, the task for you is to get rid of some of that acid. Remember, the definition of an acid is the relative hydrogen ion concentrations you have in a fluid. The more hydrogen ion concentration you have, the more acidic it's going to be. So here, you would be in some situation, we feature this as the compensation mechanism for pulmonary acidosis. This is what your kidney is trying to do. So if it gets rid of a lot of that acid, then your blood pH is going to rise. For the alkalosis one, you got this. So now you want to keep those acids, but you can, well, you don't necessarily want to reabsorb this, but you don't want to get rid of hydrogen ions. You want to retain those. So there's two parts of this. You want to retain hydrogen ions, so you want to do less of that transport, and at the same time, you want to get your bicarbonate, and that's going to be down here. So, we then featured in this unit the metabolic problems. So now here you have problems in your body that are causing you to be acidotic or alkalotic, and now it's your breathing that's going to be compensating for that. Here, we weren't so much into it, when we talked about the respiratory alkalosis and acidosis, this was the compensation mechanism. Now, this is going to be the primary problem area, ultimately, and then not necessarily the cause, but what are you going to do for it then? And now the only thing you can do is to breathe differently. So, if you alter your respirations, you're either going to reduce your bicarbonate loss, or the CO2 loss, or you're going to increase your CO2 loss. Those are the two things that you can do by either hypoventilating or hyperventilating. And then that's going to restore you back to your normal level. Remember back in the lung when we had this, what did we do with bicarbonate in that red blood cell? You converted it. That's what that bicarbonate buffer equation was in that red blood cell, into CO2, so when you exhale, you can get it. If you have it all locked up as bicarbonate, you can't do that. So that's what that was. The same thing is happening here. If you have bicarbonate coming down here, and you're going to lose this, you're going to urinate this out. If you need to reabsorb bicarbonate, you have to convert that back into CO2. Here, you can reabsorb CO2 in there, but now you have it as CO2, and that's not going to work for you either, because you can't get that into blood that way. So you have to reconvert it. Now it's going to be as bicarbonate, and you can get that back into your blood. The hydrogen ion is relatively simple, because now all you have to do is have adequate sodium in your urine, and you always have that. So now you can antiport that. When you get these hydrogen ions out there, you lose those. That's all that's going on here. So those are your two options. And you have to remember that since you're going to be antiporting these, this is a little bit more involved, even though there's more chemistry involved down here. This is more involved because you have to pay for this. You can't get hydrogen ions out of there without getting sodium ions come in there. And you have to pump those out of there, and that's going to cost you ATP every time you do that.
It means nothing is like necessary.
And here, you're not spending that other than, yeah, you've got to get some hydrogen ions out here so that you can do this reaction to do this. But it's not like you're using that to get a lot of that out of there. Here, you could be streaming hydrogen ions out of there by streaming more sodium in there, and then you'll lose a significant amount of hydrogen ions that way. Does that make sense? So that's this part. So that's the A part. B is going to be, so you'll see this, and you'll have a little thing, fill in the chart on the following page, or on the bottom of this page. So that chart will be here, and then you'll have a whole bunch of little lines here, and all those things will be now numbered. So then, this will be 1, 2, 3, 4, 5. You number them in there, and then it'll say describe, very much like we had in that kidney essay. Describe what's going on there. So you have a little description in there. All right, the B part of this would be describe the transport of the ions. And this is the paracellular transcellular stuff. Where does it occur? How does it occur? So you have several pictures in here that show you the absorption of these different ions, like this. So this one is showing you that. So here, this is all about bringing these between cells, that's that paracellular transport, and then you have in here, you've got the symporter that's going to give you the ability to take sodium chloride and potassium through a symporter, and then depending on your amount of potassium you have, you can get that right back out of there. Freebie here, except this guy that you have to pump in, and you got to kick in some ATP for. So here, it's just an acknowledgement of this. Here, the little extra thing that you got to stay is this. You're not going to get that diagram for this. So here, you got to put this in your own words. You got to, I want you to remember what paracellular and transcellular transport is, and what you have to do when you take things through a transcellular approach. So when you look at these electrolytes, here, remember, you've got glucose and you've got sodium as well. So you've got these as symporters. Glucose isn't an electrolyte, but when you have this transport, that's another way you can get sodium back in here. Again, the problem you're going to have, nothing different. That ion is going to have to get ATP to pump it back out of there. So there's a couple of these, like this one, that are a little different. That's sodium 2+ ion. That's got a little twist to it, and that it's going to cost you to do that every time you do it. What was the third part of this? What did you write down? What was the third one? The what?
So how was that about? Just filling in the chart.
This is the how. The chart is the other one, and I think that was the B one. So I think that's that.
That's
essay.
one of them, yeah, and then the concentration is the second essay.
Yeah, so renal concentration is the second essay. And that essay is kind of fun, depending on your